All right, in this part of 1 point section, we're going to be talking about something that everyone likes, and that's free money. So let's say I started with $10,000, and then I went to these 3 different banks, and now all these banks advertised something called a 20% nominal rate, and we'll talk about what that exactly means in the next slide. But I just want you to understand kind of the core intuition between these 3 different types of interest. So in this first one, in the annual compounding, I start with my $10,000, and once a year the bank looks at me. So here's t equals 0, and once a year my bank is going to give me some free money, and it's going to be 20% of what I had before. So this first year, 20% of 10,000 is 2,000. So they're going to give me $2,000, and I end up with 12,000. At t equals 2, they're going to give me 20% of what I had here, and that's going to be 2,400. And so the final amount I'll end up with here after 2 years is $14,400. Now, this next bank, remember we're only talking about the core ideas here, they're going to give me my money twice a year rather than once a year, and they're going to break it up into 2 10% payments. All right, because half of 20 is 2. So I start with my $10,000 in this one at t equals 0, and then at t equals 0.5, they're going to give me 10% of what I had before, or $1,000 to give me a total of 11,000. They'll do the same thing the next half-year interval, giving me a total of 12,100, and they will continue doing that. So they'll give me 10% of 12,100 to give me 13,310, and then once more they'll give me 10% of what I had before, and I will have a total of $14,641. A little bit more than I had before, and that's because I'm getting interest on interest. The final example is one where they're giving me money not just twice a year. You could think about, well, maybe there's a bank that does this 10 times a year, right? And they'd give you 2% of your interest each time. Maybe there's a bank that does it 100 times per year, and they give you 0.2% of their interest each time. Compounded continuously is, it's not even 100, it's not 1,000. They're giving you money, they're giving you interest infinitely many times a year. They're always giving you a little bit more money, a little bit of slices. So this one we don't really need to talk about. We can't really talk about as well what's happening in the middle because they're just giving you tiny little slices, but we can kind of get to that in a second. The total you'd end up here would be $14,918.25, so a little bit more than the bi-yearly one. And so for the main reason we made this slide is so you can have a little bit of intuition for the 3 different ways these things work. And if we'll just take a moment to notice that getting from here to here, we were adding 20% of what we had before, but you can actually think of that as multiplying your original value by 1.2. And similarly, the jump from here to here, you can also think about it as multiplying by 1.2. Here we are adding in 10%, so you can think about it as multiplying it by 1.1 for each of these jumps. And with that in mind, we can kind of think that these, figuring out what this output value here is for this input value is going to be some sort of exponential function, right? We have this constant relative rate of change. And indeed, that's what we're going to have. So let's take a moment just to write down the formulas, and we'll see that the first one is the simplest. So for our annual rate of change, the value of my account at time t is going to be my principal, the amount I put in, times 1 plus my rate, all to the power of t, right? And we can see that that works. Up here, my principal here was 10,000, and my rate was 20%, so this would be times 1.2, 1 plus 0.2, and that would be to the power of 1, and that's going to give you 12,000. Similarly, I could get 14,400 by multiplying this by 1.2 again, which would increase the exponent just according to this formula, right? Principal times 1 plus rate, all to the power of time, which is 2. The next formula is a little bit harder to link in, but you can do the same way. It's going to be our value at time t is the principal, the amount I put in first, times 1 plus not just my rate, but my rate divided by the number of times I'm compounding, because this is a nominal rate. And so remember, in my example, I did 20%, and I was doing it twice a year, so this was 0.2 divided by 2, and I would have had 1.1 here. And this isn't going to just be t up here, it's going to be n times t, because you're giving them that 10% multiple times per year. But when it comes down to it, you can just memorize these two formulas, but it'd be good if you had at least a little bit of knowledge of how it worked up here. Finally, the continuous rate is just going to be, it's actually very interesting, my value at time t is going to be equal to p, and kind of the way we can think about our continuous rate is this n going up and up and up and up, and I get something entirely different, and it's actually how e is defined, but this is going to be my initial value times e, not 1 plus my rate, but my rate times time. And so a lot of people call this PERT, P-E to the R-T. And before we move forward, we want to cover this vocabulary word of effective rate. And so to kind of get an illustration of what this is, let's go back to this original slide. And so we'll sometimes say something like, well, what's the effective rate of a 20% nominal rate compounded continuously? And so what we mean by that is, if I came back to this annual rate over here, what would this blue number need to be to get me up to the number that I had over here, right? And so the way we'll actually write that out is that the effective rate is the rate at which an annual account would need to have to make that same amount of money.